it means you've got to compress it down. So basically, to get from those sort of speeds down the bottom there, if you're running ultra high def, it's 48 gigabits per second uncompressed. So the TV industry invented all these compression technologies. It's the necessary evil because it adds artifacts and it adds delay. They set up this thing called the Moving Pictures Expert Group, which is what MPEG stands for, and they started to standardise digitisation, and the International Telecommunications Union got in on the act because they realised people were starting to run video conferencing. So it started out in the broadcast world, but it's moved here. Interesting that we've ended up with 16 by 9 instead of the Panavision, the things we get at the movies, but I'll move through that. They didn't care about latency because they were just broadcasting it. Motion JPEG is the sort of thing that a lot of your high-end digital cameras use when they record video. Basically, it just does compression on each frame. It takes the frame, it does a JPEG compression. It's fairly low latency because you just take a frame, you compress it. This is what it does to you. This is just a strange object I found, and I did compression on it. Okay, the top line is obviously uncompressed. Then I did a JPEG compression at 78% compression, 44% compression, and 22% compression. And you can see as we go down that even given the artifacts of this projector, that you're getting much loss in fidelity, both the colour and the definition around the edges. And it's interesting to note, I don't know how it looks on that screen, but the blue seems to compress worse than the brown. So they created this thing called MPEG, which uses interframe compression to get the bit rates down from 60 megabits to something usable. And what it does is it basically takes a reference frame and then it sends information about changes that have happened between that frame and the next frame. The simple way to show this is you take a scene like this, you've got a car driving down a road, it basically looks at that, it then looks at the next frame and realises that most of the image hasn't changed. And you go again and you can see that you don't have to send that much information. So that's how a lot of all modern compression technologies work. They look at the picture, they look at what's changing between frames, and they send the differences. And then every now and then they have to resync because the whole scene might change. So having done that, people now have demos of ultra high def running at 50 megabits per second. They claim it's possible to get it down to 15. If you apply that to the next generation, you're going to talk 200 megabits per second. So if you want to get a real watching experience, you're going to need very high bandwidth. So what's wrong with all this compression stuff? I think the interesting thing to me is that because you've got to go frame by frame, you've got to compare between the frames, you're ending up with what we call latency. It actually takes a while for the camera to process it before it starts to send the video out. And this is no real problem for the broadcast industry, except for those people who like to watch the cricket on commercial TV and listen to the ABC radio commentary. They're now discovering that they're totally out of sync. And people have even invented things to try and resync them. So that's an interesting change that's happening. So latency kills interactivity. It makes the effects of echo worse. If you remember that when you get into problems with echoes in a conversation, the more the latency, the more the echo you get. And in perception, it's a problem. If we could actually drop that latency right down, then people wouldn't really notice echo. It'd just be like being in this room where I can hear myself coming back, and it's okay, because it sort of just feels like I'm in a live room. Other issues, colour fidelity. Colour fidelity is very important. I've got a good example here of a charming lady who came to visit me recently, and if you change the colour balance just a little bit in the camera, you get a totally different look at what the colour of red might be. This may not be important for your hairdresser, but it's very important in telehealth when they're trying to look at people's colour of their eyes or the colour of their skin or the colour of their lips. So latency is also an issue in gaming. Telerobotics, if you're remote operating things, instruction. We've done experiments teaching people how to operate complex machinery. Again, you may want the instructor in a different part of the world. Music, you may want musicians to play together or talk about it. And the other thing is arguments. you should try having an argument over a video conference link that's got a little bit of latency. You can't get a word in edgeways with the loudest speaker, and it's a real problem. So if you can get that latency down, then you get the issue. Okay, so why is that important with the NBN? The more the bit rate, the less the video compression you do, the lower the latency. We did some experiments a long time ago, 10 years ago, in music education, and we found the first thing the problem was echo cancellers that were built into video conferencing had some funny effects in music. This gentleman here, Mark Walton, was Professor of Woodwind at the Conservatorium of Music in Sydney, and he used to teach people via video conference in places like Dubbo, Narrabri, and I sat in on a number of the classes and tried to work out what was going wrong. Basically, video conferencing units weren't designed to handle high dynamic range that you've got with musical instruments, the sudden loud, the sudden soft, the low pitch to the high pitch. But again, it worked well with headphones, and it worked for auditions for the YouTube Orchestra. People seem to think out there that the YouTube Orchestra is about people playing together on the net. It's not. It was about auditioning to play in this orchestra. We did a high-quality masterclass, and I'll just show you a very brief, hopefully, bit of that project. Glenn, we haven't got any audio. Okay, we had some IT issues earlier, so looks like we're not going to get any audio. So, the important thing I talk about a lot is telepresence. And what do we mean by telepresence? It's making you feel like you're in the same room. Now, at the moment we can't do that because it'd be nice to have a really big one of these 8K screens there, and we could really get that feeling of being together. So what we do is we run multiple views in real telepresence systems. You use the bandwidth that the NBN is going to give you to run multiple videos, different views of the room, bringing in different people, sharing spaces, sharing documents, pointing at people, and my medical friends even want to be able to do remote palpation, that is, have a haptic device that they can go and actually feel, touch someone, a patient, and say, does it hurt there? So that's the ideal telepresence world. And again, it can be used in all sorts of cases from business meetings. Body language is very important in a business meeting, and in the current video systems, it's really hard to read someone's body language. I think Peter Carter was talking about it yesterday, about, you know, is the guy in the dock looking at the judge in the eye when he's lying, or not lying, as the case may be. That's the ultimate telepresence system. I talked earlier about the telehealth system we built in Katoomba. This is just some shots from that system. It was a trolley that we wheeled up to the foot of the bed, which is where the specialist would normally stand when he's examining a patient. You'd see that we had 5 video streams running back to Sydney on an optical fibre link. They were close-ups, they were room overviews, they were medical x-rays, they were vital signs monitor information. The patient could see the specialist standing there at head height and talk to them, so they knew who they were talking to. Last thing in the world when you're waking up from a terrible accident is to have this disembodied voice saying, how are you feeling? So you really needed to feel like that person was there. And that's what the specialist saw at the Katoomba end. He had this, at the Sydney end, sorry, this is what he had, a collection of videos that he could control and see what the patient was really doing. Education. In the future, no boundaries in course content. American universities are opening up their courses to anyone who wants to enrol. This is going to make a big change. It's non-linear access to the lectures. It's group chats. Remember, I guess when I was at university, we used to sit in the library or the tube rooms after a lecture and try and work out what on earth the lecturer was talking about. Now that's all done online. Personalised or recommended content. Again, it's something you can do. You can get on and see what your friends are watching. That you can help you with your next assignment. And whole-of-life education is becoming much more important. And again, you can do that from home via the NBN. I was talking to some friends at the University of New England, and they say that a large percentage of their students are mature-age students, and they do their homework sitting on the corner of the bed in the bedroom because they want to get away from it with a laptop on their knees, which I thought was an interesting change. And of course the question I've got is what happens when 1 million students have 100 megabits from home and start accessing all this data? There's 1 million students in Australia at the moment, so you can imagine the traffic that's going to generate. What will telework look like? I think, telework from home, okay, you've got the concept of call centres. You can be a call centre operator, you can be a nurse on the 1-3 health numbers. But there's a lot more to it in the future. It's this whole always-on video to the tea room, so you can see if there's someone wandering around the corridor. You can be doing collaborative editing, sending documents back and forward, talking to more than one person. You may want to talk to 3 or 4 people. The other concept that the New South Wales government is exploring at the moment is called a teledoc centre. And I talked earlier about you may need some specialised equipment. This shows a setup we've got. You may need a good quality camera, you may need a document camera or a document scanner, or you may need some other sort of document sharing, expensive software. And what they're looking at setting up in regional centres is a building with maybe 20 or 30 rooms equipped with the specialised equipment connected to the NBN that let people work from regional areas back into city-based or international companies. And the other advantage of these teledoc centres is you come in there, there's a coffee shop, you actually get to talk to people. Teleworking from home is all right for 1 or 2 days, but it would drive me mad if I did it every day. I wouldn't get to talk to anyone. So these teledoc centres are certainly something that's, there's experiments going on in Australia right now about setting them up. Virtual counter we've been talking about on our display outside, a new concept for the service delivery. Again, face-to-face videos, not accurate. How do you get that virtual document out of the computer screen? We've built a counter for delivering services, and basically it's about face-to-face video. You may have biometric ID. You may want to bring in a third-party interpreter or a specialist, or a document camera or a room overview. And I was even able to explain this to Malcolm Turnbull, so he got it, which is good. That's what it might look like. Again, the multiple videos, the shared documents, sort of thing. Again, I talked earlier about Web 3.0, the next generation technology. We're working on that. Basically, it's a browser technology that lets you put all those videos into the one browser window. So there's none of this, update your Flash, update this plugin when you log onto the website. It's all going to come in the next generation of HTML5 browsers. It's going to be all in there, and you can have multiple video streams running there as well. And the virtual counter is basically going to look like that. That was a screen placed in portrait mode, not landscape mode, showing that. That's our prototype currently working in the lab. Social TV, again, there's Pete Alcina said today there's massive amount of video being uploaded to YouTube. I think it's about 72 hours every minute of new content. How do you find it? In the old days, we used to gather around the black and white TV and talk together. In the 21st century, people have gone off into their bedrooms. Will the smart TV bring us back into the home, bring us back together as a family? That's an interesting question. Will it be the set-top box? I mean, I love it when the TV comes with an Ethernet connection on the back. It's an interesting change. So, how do you find those 72 hours? Basically, you need intelligent digital services that give you recommendations. They tell you what's there, they tell you what you might like, and they tell you what your friends are thinking. And so social media operates through that. So our system that we're currently trialling at the University of New England and about to trial on the NBN in Sydney basically lets you log onto your Facebook and Twitter account and exchange ideas on the content with your friends.